When we have functions, we like to use function notation. Function notation is really just using a letter, such as f, as the name of our function. So the name of our function is f. And then in parentheses, the variable that we're going to denote as the input that is changing. So your input variable is x. So in the first example, find f of 1, we're going to input 1 into the function f. And we're going to simplify. So when I put a 1 in, let's go back here and use gray. So when I put a 1 in, I'm going to have, instead of x plus 4, 1 plus 4. And then instead of x cubed, I'm going to have 1 cubed minus 4 times 1. And I am going to move this over here because that's going to allow me to continue to work off to the right. 1 plus 4 is 5. And then I have 1 minus 4 is negative 3. So I'm going to move the negative to the numerator and I get negative 5/3. Whenever you have a fraction that's negative, if you're writing this with your handwriting and not with a computer where you're typing in your values, you always want to throw that negative to the numerator. It's good etiquette is what they will say. It's good etiquette. Okay, f of negative 1, we're still going to use the f function. Wherever we see x, we're going to put negative 1 in its place. So negative 1 plus 4, and then we have negative 1 cubed minus 4 times negative 1. Well, negative 1 plus 4 is 3. Negative 1 cubed is negative 1. Negative 4 times negative 1, negative 4 times negative 1 is positive 4. 3 over 3. Let's make sure I did this right. Negative 1 plus 4 over negative 1 cubed minus 4 times negative 1. And I did. I got 3 over 3, which is 1. When the fraction goes away, sometimes it's too good to be true. I step back and I make sure that I've got it right and I didn't make a mistake. Okay, we're going to put a 0 in. 0 plus 4 over 0 cubed minus 4 times 0. This is an interesting one. I've got 4 over 0. Dividing by 0 is undefined. It cannot divide by 0. So f of 0 is undefined. Okay, let's try a negative 4. Negative 4 plus 4 over negative 4 cubed minus 4 times negative 4. Negative 4 plus 4 is 0. And in the denominator, I have negative 64 plus 16. Now, I could go through the motions and figure out what negative 64 plus 16 is. I believe it's negative 48. But as soon as I have some number other than 0 in the denominator, but I have a 0 in the numerator, I know that 0 divided by anything other than itself is 0. And then we'll try f of 2. Hopefully you're maybe a step ahead of me, getting answers and then checking them along with me. 2 plus 4 is 6. 2 cubed is 8. Minus 4 times 2, that would be minus 8. 6 divided by 0 is, hopefully you got it, undefined. Undefined. So we can see that there are some values that we can't put in. This is interesting. We could not put in, so I'm going to say 0 was a problem. That was an input that was a problem. And 2 was an input that was a problem. How can we determine if those are the only two problems? Is there another one out there? Well, let's take a look at this function. So what happens when we have this rational function? A rational expression is a fractional expression. Fractional expression with a variable in the denominator. Well, we know that the denominator cannot equal 0. The denominator cannot equal 0. When the denominator equals 0, those values are restricted from the domain. So what values are restricted? Restricted. Restrict. R-E-strict. Restricted. Well, you're going to set the denominator equal to 0. You're going to solve, and those solutions are restricted values from the domain. Okay, so we have x cubed minus 4x equals 0. I'm going to factor out an x, which gives me x squared minus 4. So I've got x, I'm going to continue to factor, x plus 2, x minus 2 equals 0. And then I'm going to set each variable factor equal to 0. So I have x equals 0, x plus 2 equals 0, and x minus 2 equals 0. Well, x equals 0 is going to be one restriction. We knew that up here. X equals negative 2 is a restriction. That we did not know. X equals 2 is a restricted value. That one we knew. So there was another one that was hiding in there. So our domain are all values except for 0, negative 2, and 2. So you can say x such that x is not equal to negative 2, 0, or 2. I love this notation. It's called set builder notation. This notation is very easy and clean, but many have started using more often than not interval notation. So that would be negative infinity, and then when you get to negative 2, it's not allowed. So you stop at negative 2, and then you start back up at negative 2, and you go to 0, and then 0 is not allowed, and then you go to 2, and 2 is not allowed, so you go to 0. So interval notation is the one that I boxed. However, if you're not told that you have to use interval notation, I like the set builder notation that I showed you in the beginning. Okay, what is the domain of f of x is equal to the square root of 12x minus 2x? Here we have a radicand. So we have a radicand and an even index. So I'm going to explain to you what this is real quick. The index is the number that goes right there. It tells you your root, and then your radicand is the expression inside the radical sign. When the index is even, there are restrictions. Non-negative results only. So you want non-negative results only. So the radicand has to be greater than or equal to 0. That's what that means. I'm going to highlight this. Non-negative results only. Which means you want the radicand to be greater than or equal to 0. So you want that expression that's inside, for instance, 12 minus 2x, you want that to be greater than or equal to 0. So I'm going to subtract 12 from both sides. I get negative 2x is greater than or equal to 0. Is greater than or equal to negative 12. And then I'm going to divide by negative 2. And whenever you divide an inequality by a negative, you have to flip the symbol, so x is less than or equal to positive 6. So the domain would be x such that x is less than or equal to 6, or in interval notation, negative infinity to 6 with a bracket. So when the index is even, and even happens when it's empty. When it's empty, it's the most common, it's the square root, which means your root is 2. So we have domains where we have to worry about the denominator, and domains where we have to worry about the radicand. So hopefully these 2 videos gave you an example of each one that you feel pretty comfortable with.